Okay, so today we're going to look at categorizing patterns. So in linear sequence, the differences between consecutive terms, so consecutive means right beside each other, so 2, 3, 4, okay, so they're all consecutive terms. Also called the first difference is always constant. Okay, so for linear, if it is a linear sequence, the first difference is always going to be the same. Right. If the difference between consecutive numbers, okay, so numbers that follow each other, is not constant, then we say the sequence is non-linear. Okay, so a linear pattern, if we were to draw that, it would look like a straight line. Okay, so now we're going to deal with two other types of patterns. We could have a quadratic or an exponential. Okay, so quadratic pattern here. Okay, so we still get, right, so these are my consecutive terms. Okay, so they're right beside each other. So I have 7, 8, 12, 19. Right, so I do the exact same thing as what I've done before. I get my first difference, okay? So the difference between 7 to 8 is plus 1. The difference between 8 to 12 is plus 4. And the difference between 12 to 19 is plus 7, okay? So that's my first difference got, okay? But we can see here that these numbers are not the exact same, so it cannot be a linear pattern, okay? But then I look to get my second difference. The difference between 1 to 4 is plus 3. And the difference between 4 to 7 is plus 3. Okay, so my second difference is the same. If my second difference is the same, we say that it is a quadratic pattern. Okay, so in this case, the pattern is referred to as quadratic pattern. When the second difference is a non-zero constant, the pattern is quadratic. So we know first difference has to be linear, second difference has to be quadratic pattern. The only thing I can say about this, if you were to graph a quadratic, we'd know it looked like either a happy face or a sad face. It would be a curve. Okay, right, now I'm looking here at exponential patterns. Okay, so here I have 10, 20, 40, 80. Okay, so that's another example of a non-linear pattern. Okay, so I do the exact same step. Okay, I get my first difference. So the difference between 10 and 20 is plus 10. The difference between 20 and 40 is plus 20. And the difference between 40 and 80 is plus 40. Now I go on and get my second difference. The difference between 10 and 20 is plus 10. And the difference between 20 and 40 is plus 20. Okay, there we can spot, girls, that our second difference is not the same either. Okay, so it cannot be a quadratic pattern. It has to be an exponential pattern. There's only three types of patterns that you can have, either linear, quadratic, or exponential. So if it's linear, my first difference is the same. If it's quadratic, my second difference is the same. And if your first or second difference are not the same, then it has to be an exponential pattern. Okay. So the difference between each term is not constant. The second difference is also not constant. So a sequence or pattern that involves doubling or tripling is called an exponential curve a pattern. If you were to graph an exponential pattern, girls, it would look like a Nike tick. Okay, so it would get be growing very, very fast and suddenly. Now I have an example. For each sequence, identify the type of sequence, linear, quadratic, or exponential, and give a reason for your answer. So I have this sequence here. So it's 14, 10, 6, and 2. So the first thing I always have to do is I have to get my first difference. Okay, so I get my first difference between 10 and 14 and 10, I'm going down minus 4. Between 10 and 6, I'm going down 4. Between 6 and 2, I'm going down 4. My first difference is the same, so that means it has to be a linear pattern. Okay. What I have then, okay, so it's 14 to 15, 15 to 21, and 21 to 32. Okay, alright, so 14 to 15, I get my first difference is plus 1. 15 to 21, my first difference is 6. And 21 to 32 is plus 11 also. Okay, my second difference then between 1 and 6 is 5. And then my second difference between 6 and 11 is plus 5. My second difference is the same. Okay, so that means it has to be quadratic. My first difference was obviously different, so it couldn't have been linear, but my second difference is the same, so it has to be quadratic. So this sequence is a quadratic as the second difference is the same. And here I have, okay, so I have 3, 6, 12, and 24. So I get my first difference, so the difference between 3 and 6 is plus 3, the difference between 6 and 12 is plus 6, and the difference between 12 and 24 is 12. Okay, so my first difference is clearly not the same. Then I get my second difference. Okay, so my difference between 3 and 6 is 3, and my difference between 6 and 12 is 6. My second difference is not the same either, so that means it has to be an exponential pattern. Okay, and we can see here that it actually is an exponential pattern because 3 times 2 will give me 6, and if I was to get my next pattern, it would be 6 times 2, and so on. Okay, so it has to be an exponential pattern in this case. here's another example. For each quadratic sequence given below, find the start term, the second difference, and the next three terms. Okay, so I have 2, 5, 12, and 23. So my start term in this particular example is 2, and I was asked to find my second difference. Okay, so what I have here is I have 2, 5, 12, 23. Okay, so my difference between 2 and 5 is 3, and my difference between 5 and 12 is 7, and between 12 and 23 is plus 11. That's my first difference. Now I have to get my second difference, so the difference between this and this. So the difference between 3 and 7 is plus 4, and the difference between 7 and 11 is plus 4 also. So my second difference is 4. And then second difference is 4, and I was asked to find the next three terms. Okay, so term 1 was 2, and term 2 then has to be 2 plus my 3, okay, because my second difference is 3. So 2 plus 3 is 5. Now I go on, okay, so my term 3 has to be 5 plus, okay, I'm going to have to add on 5 plus 2 gives me 7, okay, so it's going to be 5 plus 7, and that will give me 12. Then I bring down my 12, okay, because my difference is 3, I need to add this on, okay, so it's going to be 3 plus 7, and 3 plus 7, no, that's not how I do it, it is, my second difference is actually 4, okay, so my term 1 is 2, okay, and I go 2 plus 3 will give me my 5, okay, because the difference between my first two was 3. Then if I look again, okay, 3 plus 4 will give me 7, okay, so it's going to be 5 plus 7, that gives me 12. I bring down my 12, and I need to add 7 plus 4, because my second difference is 4, so 7 plus 4 gives me 11, so 11 plus 12 plus 11 gives me 23. I bring down my 23, and I need to then add 11 plus 4, because my second difference is 4, so I get 11 plus 4 gives me 15, so I have 23 plus 15, and that gives me 38. I bring down my 38, and I have to go 15 plus 4, and that will give me 19, and add these together, it gives me 57. Bring down my 57, and because my second difference was plus 4, I go 19 plus 4, and that gives me 23, and my seventh term will have to be 80. So the next three terms are 38, 57, and 80. If you wanted to, you could have went off and did it like this. So we already had 2, 5, 12, 23, okay, and we know this was plus 3, this was plus 7, and this was plus 11, and we figured out that this was plus 4, this was plus 4, okay, so what I could have done if I wanted, I would have to do plus 4, I just did it on my table, here would have to be 15, okay, so to get from here to here I would have had to add, so 23 plus my 15, I could go again underneath, so I can draw it this way as well if I don't like using my box method. The next example that I have here is minus 1, 2, 0, minus 7, so my start term is minus 1, okay, and I have to find my second difference, okay, so going from minus 1 to 2, I'm going up 3, and then going from 2 to 0, I'm going down 2. And going from 0 to minus 7, I'm going down 7, okay? So my difference between plus 3 to minus 2 is minus 5, and my difference between minus 2 to minus 7 is also minus 5, okay? So what I have here, so my term 1 is minus 1, okay, and my common difference then is, my second difference is 5. So then I do the exact same method here, so I have minus 1 plus my 3, and that gives me 2. Bring down my 2, so then I have 2 minus 2, and that gives me 0. Then I have 0 minus 7, and that gives me 7 minus 7. Bring down my minus 7. So if you look up here, girls, I would have to find, if I was going out this way, right, I'd have to go minus 5 again. So I go minus 7 minus 5, that gives me minus 12, okay? And then I go minus 7 minus 12, that's what I've written down here, and that gives me minus 19, okay? Then I bring down my minus 19, okay, and I have to go minus 12 minus 5, that will give me minus 17, and that's equal to minus 36. And then I do the same here, and I get my three next terms are minus 19, minus 36, and minus 58. And that's it, fully completed.